I thought I'd make a short video on this latest version of this single motor robot toy thing I've been building. It's an updated version of this guy I showed in my last video. This one would go forward, left, or right. It just worked by these cams selecting whether the wheel was driven or not driven. This one has all four functions: forward, left, reverse, and right, in that order, I believe. That's the way the cams are set up. I'll demonstrate it working now. Works by an IR control, sending out Sony codes, received by this infrared receiver, hooked to an A-Tiny85 microcontroller, driving one of the cheap motor drivers. I can't remember the name, L something. I'll show it working. First we go forward, stop, reverse. You can see it indexing to the proper position. Stop. We'll have it turn to the right. It's right. Stop. Back to its left. Stop. Forward. Then to the right. Just straight to the right, not stopping. Stop. You can see it works pretty well. You can drive it around. I'll show a closer view of it working now. It works similar to the way the other one worked, with this starting out with this floating pinion coming off the drive motor. It's a little N20 gear motor setting down in there. On this one, it's right here. Here's the gear that is driven by the N20 motor. This floating pinion, depending on the direction the motor turns, will either select these gears that drive the final wheels. They turn in opposite directions, so a little selector arm selects which gear will be hooked to this wheel. The wheels are driven independently, so each side has its own setup. Let's see if I can get a picture in there. As these push rods move up and down, they select whether the motor is driven in forward or reverse. When the N20 motor runs in reverse, it drives this cam and indexing mechanism. There are cams for each side. They're 90 degrees out of phase, but identical other than that. This little wheel here is just, it actuates the switch, which is how a microcontroller keeps track of what direction it's going. It depends on being started up in the forward direction. Then it just keeps track from there, just by counting. I've also got a little dedent here. This is not the way to, but I will do it in the final version if I ever get to it. There's also some magnets helping to help the dedent. I was just trying to get it to work. Eventually I'll be using a Geneva mechanism, which I've already started working on. I'll show it working now with a remote. First we'll go forward, which I believe it's already in, so it won't do anything. Stop. Now reverse should make it index twice. Stop. See right, I believe it'll index once. Stop. Left should index twice. You see it always runs in the same direction. Reverse would, see, I can't remember where I'm at now. No, we're one away. We should be two away from forward. Hopefully this will show these mechanisms moving up and down, selecting which direction each wheel is driven by. It's not really that complicated. It's just a lot of moving parts. One of the things I had trouble with was this floating gear. I had to put a spring on it to get a little tension on there. Otherwise, it would, when it ran in reverse, I think a lot because of gravity, it would just sit there and spin in the middle. This gives it a little tension, which will help drive it up into the indexing mechanism gear. The other things I've had trouble with, you can see these rubber bands. This is just kind of a kludge to get it to work at all. They provide some force to make when the cams drive the push rods up, but when they go down, it's the force of these rubber bands. And there's also a couple of magnets that I attempted to use, but this is not really working the way I wanted in the final version. If there is one, I'll come up with something better, probably cams that push and pull it both ways. That would be a more positive solution. This is kind of a tricky thing to set up. I put some D-dents in the little indexing mechanism here, but the little switch, spring-loaded switch, actually helps to keep it in the right place. Of course, in the final version, I would probably go to something like this. This is a Geneva mechanism. That's about the size that it'd have to be too. Just running it with a little test box I made. You can see this provides a more positive index. It could probably be made tighter than that. It's the first time I've ever drawn one of these up in CAD. It was pretty interesting. This is just a test mechanism. It would go right. This wheel would be driven by this gear, and the actual indexing mechanism would drive the cams. So it would go in there like this. That's for the future when I get time. I believe that's mostly what I wanted to show. I'll show you the back side of it. You can see these are the counter-rotating gears that provide the forward or reverse direction depending on which one is selected. They're hooked up all the way through these gears right down. I don't know if you can see it or not, but this is a little idler gear. That mechanism looks like this. This is what's driven or pulled by the push rod, and it selects which gear drives the wheel. The wheels are independent of each other. They have to be naturally. You can see that. It's kind of a hard little thing to build. Well, I think that's all I wanted to show. Thanks for watching.